Good morning. Yesterday we have started with studying the concept of convolution summation for discrete time signals. Today let us start with that point. Let me start by sharing my screen. Okay. So we have seen that to find the output response of any of the system that can be calculated by using this relationship, that is output response is equals to the input that is being given to the signal, and we have to perform the convolution with the impulse response, and this is being calculated by using the relationship yn is equals to summation k is equals to minus infinity to infinity x of k h of n minus k. So this is the formula that is to be used for performing the convolution or calculating the convolution to find the output response of any of the system given the impulse response of the system. There are a number of methods that are being used for performing this convolution. Among them, one is graphical representation, second one is mathematical formula, third is vector form or tabulation method that we have studied in the previous class, and last one is simple multiplication form. So today we are going to start with the method number 2, that is by using the mathematical formula. We have seen that if yn is the output of any system where xn is given as an input and hn is the impulse response of the system, then output can be calculated by performing the convolution of xn with hn. And this convolution can be calculated using this relationship, that is yn is equals to summation from k is equals to minus infinity to infinity x of k h of n minus k. Now let us see how we are going to apply this formula for calculating the output response of the system. So here we have given one example. The impulse response of the system is given as hn, which is 2 and 2. And the input to the system that is given over here is 1, 1, 1, 1. Since here zeroth sample is not marked, we will consider that this one is our zeroth sample, and here for xn this is our zeroth sample. By looking into this, we will find that the value of x0 is equals to 1, x1 is 1, x2 is 1, and x3 is also equals to 1. Similarly, if we look into this hn, sequence representation of this hn, we can find that h of 0 is equals to 2 and h of 1 is equals to 2. Right, now we will start using this formula. The formula for calculating the output, we know that its limits are extending from minus infinity to infinity. But here we will be changing the limits from k is equals to 0 to 3 because this is the start and end index of your signal xn. So we have to calculate this for only the values of k which are in between 0 to 3. We don't have to go for minus infinity to infinity. Now substituting this value, we are going to get yn is equals to x of 0 by substituting k is equals to 0, hn here everywhere we have substituted k equals to 0. Similarly x of 1 h of n minus 1 by substituting k is equals to 1, x of 2 h of n minus 2 by substituting k is equals to 2, and x of 3 h of n minus 3 by substituting k is equals to 3. So for calculating the output, we have to calculate this response. Okay, now we already have calculated that the different values of x0, x1, x2, x3, similarly h0 and h1. Now let us start by substituting different values of these in the formula for yn. Let us start by calculating first y of 0. Our y of 0 will be equals to, in this expression we will be substituting and equals to 0 everywhere. So this will be coming out to be x0 h0, x1 h of minus 1, x2 h of minus 2 plus x3 h of minus 3. Now we will substitute the values of x's and h's from the value that we have written over here. By substituting these values, we will substitute x0 equals to 1, h0 is equals to 2 from here. X of 1 is 1, h of 0, h of minus 1 is 0. Likewise, by substituting various values, we are going to get over here, and this is 1 into 2 plus 1 into 0 plus 1 into 0 plus 1 into 0. So we are going to get the result that is equals to 2. Similarly, we can calculate y of 1 that is equals to by substituting n is equals to 1 in this first relationship, we are going to get this formula. And here when we'll substitute the value of x0 and h of 1 that are 1 and 2. Similarly, x of 1 and h of 0, x of 1 is 1, h of 0 is 2, that will give you 1 into 2. Similarly, x of 2, h of minus 1, x of 2 is having the value of 1 whereas h of minus 1 is 0. And at last, x of 3, h of minus 2. X of 3 is 1, whereas h of minus 3 is equals to 0. By solving this, we will get 2 into 1 is 2, plus 2 into 1 is 2, plus 0 plus 0. So ultimately, we are going to get the result that is equals to 4. Similarly, we can calculate the value of y2 by substituting n is equals to 1 in this particular expression. We'll get x0 h of 2 plus x of 1 h of 1 plus x of 2 h of 0 plus x of 3 h of minus 1. Then we will substitute various values of x0, h2, x1, h1, x2, h0 by looking into this table, right? When we'll substitute this, we will be able to calculate the value of y2 coming out to be 4. Similarly, y3 can be calculated by substituting n is equals to 3 in this expression. So by substituting this here everywhere n is equals to 3, so this will become h of 3, h of 3 minus 1 that is 2, h of 3 minus 2 is 1 and h of 3 minus 3 that is h of 0. When we'll substitute the values over here, we'll get 1 into 0 plus 1 into 0 plus 1 into 2 plus 1 into 2 that is coming out to be 4. Similarly, we can calculate y of 4 by substituting the value of n equals to 4. So we'll get x of 0 h of 4, x of 1 h of 3. These all values we are calculating using this relationship only and substituting various values of n. So after solving this, we have obtained y of 4 equals to 2. So till now we have calculated y of 0 is 2, y of 1 is 4, y of 2 is 4, y of 3 is 4 and y of 4 is also coming out to be equals to 2. So from here we can say that y of n is equals to 2, 4, 4, 4 and 2. And here this 2 is representing the 0th sample. So we have put an arrow mark over here for representing this 0th sample. So this is how we can calculate the output response of a system by using the mathematical formula that is given for finding the convolution. Here one question may arise that what are the values of yn that we have to calculate. So for this you can apply a simple trick that you have to look into the lowest indices of hn. Like here hn is having the value of h of 0 and h of 1. Similarly, if you look into the indices of x of n, it is starting from x of 0 and extending up to x of 3. So if you look into the lowest indices of h and x, they are 0. So 0 plus 0 is 0. So you have to calculate the value of y0. This will be the lower range, and here if you add the highest indices of h and x, that is 3 plus 1, that is coming out to be 4. So you have to calculate the value of y till y of 4. So the range of values that you have to calculate is from y of 0 to y of 4. If you'll try to find other values of y, that is y of minus 1, y of minus 2, you are going to get these values as equals to 0. Similarly, if you'll try to find the values that are higher than this y4, that is y of 5, y of 6 and so on, these values will also be coming out to be 0. So here the simple trick is if you have to find what are the values of yn that you have to calculate, so you can calculate it or you can find it by first summing up the lowest indices of both the sequences that you are going to perform the convolution. Here in this case 0 plus 0 is going to give you 0. Similarly, you can perform the addition of highest indices of both the sequence. Here in this case this is 1 and this is 3. So you can calculate the values of y from y is equals to 0 to y is equals to 4, and this will be the complete sequence. Before this y0 and beyond this y4, you are going to get the output equals to 0. So this is how you can apply the convolution formula mathematically to find the output of any of the sequence. Okay. In the next class, we will see how to apply the graphical convolution for finding the output response of the system. Thank you very much.